need just the second row and the third column, or a subgrid from a larger data set, indexing and slicing in Numpy makes this super easy. In this video, we're going to talk about how do we index array by position, slice rows and columns, and we'll understand the difference between views versus copies, which is a common source of a lot of bugs. Let's say I have this array here, and this is Numpy array, where the values are 10, 20, 30, and the second row or the second array is 40, 50, and 60. If we execute what that looks like, here's the data set. So if I wanted to get the first row and the first column or the second column, I would do something like this. Array 0, 1. This will return back the element in the first row at the second column, which is 20. If you wanted to get all the rows for the last column, it would look something like this. Array all rows, for the last column, which is index 2. If we run that, we get 30 and 60. What if I wanted to get row 1 and all the columns? That would look like this. Array, give me a row 1 or index 1 and all the columns, which will give us 40, 50, and 60. Unlike Python lists, slicing in Numpy doesn't always give you a fresh copy of the data. It basically gives you a view, a window into the same original data. That means if you extract a certain slice and you store it into a new variable and you modify something in that new variable, you'll realize that you've also modified the original data, because all what you did is that you took a window into the original data, you made some changes to it, which applies to the original. Let's see what that looks like. So over here, I'm going to go ahead and create a new array. And this is Numpy, a range of numbers from 1 to 10. And I'm going to reshape that to make it 3 by 3. If we look at what array 3 looks like, let me do that in the previous cell. Array 3. Here we go. Now, if I created a subgrid of that, and I'm basically extracting array 3, 0 through 2, and 1 through 3. Let's see what this sub looks like. Here we go. We basically get the first 2 rows, and we get the second 2 columns. So we get the 2, 3, 5, and the 6. Now, what if I try to modify the sub? So the item at index 0, 0, I want that to be 999. If I print out the sub, we've modified that first item in there. But what if I also tried to print out array 3? You notice that we've modified the data in the original set as well. So all what this sub here does is that it gives you that window into the original grid, and whatever changes you apply into the sub also applies to the original grid that you've extracted the slice from. If we wanted to avoid that situation, we would call the copy function when we're doing our slicing. Here's what our sub looks like. Keep in mind, we've already modified the value. This is why these numbers here have been updated. And here, if I modify the item in 0, 0, or at the first row, first column position, and we modify that back to the number 2, and we hit enter, here we go. Our sub has been updated. But if I try to see what does our array 3 looks like right now, you'll notice that the value has not changed, because at this point, this became a copy. It is not just a regular view into the original data set. So let's wrap up. Indexing and slicing are very powerful tools that you could use in your Numpy operations. But keep in mind that when you do slice something, you're only getting a view into that original data. But if you want to avoid that, you can create a copy of this data set using the .copy function. And that will allow you to protect the original data, perform operations onto that subgrid that you've extracted without applying those changes to the original data set. Now, next, we're going to learn how do we reshape arrays, how do we flatten them, and how do we stack arrays together.